This video is going to be about converting to and from scientific notation. So let's look at the first example. Here I've got the number 3,250,000, and I want to write that in scientific notation. So here's the process I'm going to use. Starting from the left, I'm going to take that first digit, the 3, and write that followed by a decimal point, and then I'm going to write the following digits until I get to the zeros. I'm not going to worry about the zeros. So I've got 3.25. Now, what I've done was I've taken a very big number, 3,250,000, and I've made that a small number, 3.25. I've made it 1,000,000 times smaller. So what I'm going to have to do is make it 1,000,000 times bigger by multiplying it by 1,000,000. So I'm going to take that 3.25 and multiply it by 1,000,000, but the 1,000,000 will be in a form of 10 to some power. To find the power, I can do two different ways. One is I can think about 1,000,000. In fact, I'll write the number 1,000,000 down. And I see that 1,000,000 is a 1 followed by 6 zeros. So the number of zeros you have after the 1 is the power of 10 that you need. So that'd be 10 to the 6th. Another way to think of that would be in the original number, 3,250,000, I put the decimal point after the 3. After where that decimal point was, there had been 1, 2, 3, 4, 5, 6 more digits. So I'm going to take that number of digits, and that's going to be the power of 10 that I use. Okay? Let's take that process and do it with another number. So let's say I have 436,000. And I want to convert that to decimal notation, to scientific notation. So I take the first digit, the 4, follow that by a decimal point, and then a 3/6. I've taken a big number and made it smaller, so I have to multiply it by a big number to make it big again. I'll multiply by a power of 10. It's going to be 10 to some power. Let's see what the power is. After the 4, when I put my decimal point down, I lost 1, 2, 3, 4, 5 decimal places, or 5 digits. So I'm going to have 10 to the 5th power. Okay? So that's the whole process of going from standard notation for a large number to scientific notation. Let's do an example where we go back in the other direction. So let's say I've got 2.35 times, well, I don't know, 10 to the 4th, and I want to convert that to standard notation. Well, I'm going to take that 2, and then after the 2 I had a 3.5, so I've got 235, but that 2.35 was multiplied by 10 to the 4th. So what I want to do is I want to go to the place after that first digit and then add 4 places. I've already got a 3 and a 5, so I have to add 2 more places, which I'll do in the form of zeros. So I've got 23500. I'll put a comma in so I can read that in the standard way. That's going to be 23,500. And if you want to check this, you could go back from this 23,500 and make sure we can get to 2.35 times 10 to the 4th. Okay? Now, I can take that same kind of process and use it for very small numbers. So for instance, let's take this small decimal, 0.000728, and convert that to scientific notation. Now, this is a small number. What I'm going to do is I'm going to find the first non-zero digit, which is a 7. After the 7, I'll put a decimal point in. Then I'll put my remaining digits. So I've got 7.28. And now I've taken that small number and made it quite a bit bigger. So I have to multiply it by a small number to make it small again. I'm going to use a negative power of 10. Negative powers of 10 are small numbers. Okay, so let's see what I've got here. Basically what I did was I took the original decimal point and moved it to the spot after the first non-zero digit. I moved it 1, 2, 3, 4 places, which means I want to have 10 to the negative fourth as the number I multiplied that 7.28 by. Okay? Let's look at another example. 0.0097. Okay, I take the first non-zero digit, that's a 9, put a decimal point after it, and write the following digit or digits. So I've got 9.7. Now I'm going to multiply it by a negative power of 10. To find what that negative power is, I go from where the original decimal point was to where the new one is. That means I went over 1, 2, 3 decimal places. So I'm going to have 10 to the negative third. And as with big numbers, I can reverse this process to go from scientific notation to standard notation. So if I've got a number like 6.28 times 10 to the negative fifth, I'll take that 628, it had been 6.28, and I want to add a bunch of zeros before it, and then before those zeros a decimal point. So I'm going to go to where the decimal place was in my original number. It was 6.28. And in my new number, I'm going to go from the place after the 6 backwards to the left 5 decimal places. So the first decimal place will be taken care of by the 6, and then I'm going to have to add some zeros. I'll have to add 4 zeros, and then decimal point going from right to left. And I'll add another 0 in front of that. So 6.28 is going to be 6.28 times 10 to the negative fifth is going to be the same as 0.0000628. And once again, if you wanted to check that, you could look at this in reverse order and make sure you get back to where we started. Okay, so that's about it. Take care. I'll see you next time.